All right. Couple people still checking in. If you haven't done that, please do so. Today, what I want to do is go over a little bit more in depth about what R8 was actually asking. Okay. And I get that people could actually do it, uh, but the form of their answer was probably just wrong. Okay. So you're probably doing exactly what I told you to do last class. I just forgot that we needed to rationalize it and not have an actual decimal. Okay. And I attempted to answer that question, um, I think on Wednesday with that email that I sent you. So I sent you a PDF. Um, I forgot what it was titled, but it had all these values that you see up on your screen. Um, and before we actually do an example, I want to tell you about kind of where those came from. And I'm not going to expect you to know this, but it can be very helpful for you on the ACT uh, and for next year. Okay, so I'm not going to require you to actually know where these values came from, but you should know that they came from somewhere, and really you should just kind of know them. Um, I realize that's hard at first, but y- y- we're gonna have to start to know these. Well, I expect you to know them all this year, probably not, but you should know about them, um, and you should probably know one or two values just right off the top of your head. Okay, so uh, your homework R7 and R8, I'm gonna have that due next class. Okay, so not today, but uh, Thursday, so you can have a little bit more time and kind of wrestle with this concept. Okay, so uh, on this screen, we have the values that will allow you to actually answer the questions in R8. Okay, so these top 9 values, those are the things we're going to be using. Okay, so sine of 30 degrees, that is 1/2. Sine of 45, that is rad 2 over 2. Sine of 60, that is rad 3 over 2. All right, so again, we're dealing with square roots, we're dealing with rationalizing fractions, and we're dealing with right triangles. Again, kind of the same thing we've been dealing with the last couple of weeks. Okay, so for example, actually, before we get there, a little bit about where these values actually came from. I'm going to make this just a little bit bigger. So there are kind of two different types of trig. There's the trig that we're learning right now, which is solely based off the right triangle. But where it actually comes from is this unit circle. And on this unit circle, you have a whole lot of different angles. You have a whole lot of different x, y points. Okay, so angles and x, y points. That's really what we're worried about. These things, including pi, those are actually angles, but we're not going to worry about that for now. That is a different measurement of an angle. Don't worry about these middle values. And really, don't worry about anything over here in other quadrants. We're just worried about that top right quadrant. Okay, there will be use for that later. That comes in algebra 2, that comes in pre-calculus. Right now, we're worried about the top right-hand corner. And where these values actually come from is that with certain values, if you have that angle, so in this case, we're talking about 30 degrees, if we put that angle on a unit circle, we will get that angle intercepting the circle at this point. And that point, if you cannot see it, rad 3 over 2 comma 1/2. Okay, and what sine is actually giving the y value of that. So it's just spitting out 1/2. So if we go back up here, sine of 30 degrees, which is exactly what we took, sine of this angle is 1/2, and that's just the y value for that point. Okay, and it's the same thing kind of going around the circle. Sine of 45 gets this y point given 45 degrees. Sine of 60 gives rad 3 over 2. cosine, then we can go cosine and we can do tangent. Okay, that's where that's actually coming from. Again, not expecting you to know that right off the bat, but there is a reason for all these numbers. These aren't just random. They come from this unit circle. So if you're confused in that by that in any way, don't worry about it right now. That's just the reasoning behind some of these numbers that you're seeing up on your screen. All right. So yeah, sine gives you the y value, cosine gives you the x value, and then tangent gives the ratio of those two things. All right. Again, don't fret about that too much just yet. That's stuff for later on, and maybe not even next year. Okay, but they give us the values that we need in order to work with these problems that we saw in the homework last night. Which, for example, is this right here. So given this right triangle, we want to find GH. So we want to find this side. All right. And we're given an angle and we're given a side. So first thing that we need to do is we just need to define what sides are what. So from our right angle, if we draw a line to the other side of the triangle, that is always our hypotenuse. If we draw a line from our angle to the other side of the triangle, that's our opposite side. And then the leftover, that's the adjacent. Okay, so from this triangle, we need to know the angle and what we're trying to find. So we're trying to find the adjacent given the hypotenuse and the angle. All right, so let's just label what we have. We have this angle theta, that's 30. We have the hypotenuse, that's 6 rad 3. And we need the adjacent. So we have to take that and solve for the adjacent using one of those sine, cosine, and tangents. Okay, so since we have hypotenuse and adjacent and an angle, we're going to use cosine. So we know that cosine of our angle gives us the adjacent side over hypotenuse. And then really we're just substituting in what we know. All right, so theta in this case, that's 30. Adjacent, we don't know. And hypotenuse is 6 rad 3. Okay, and again, we can even substitute one more time because we know what cosine of 30 is given the values at the top of your screen. So we know that cosine of 30 is rad 3 over 2. And then everything else stays the same. So I want to pause there for a second. Are there any questions over what you see on your screen so far? How do we know the value of cosine of 30? Is it just because you wrote it down earlier? Kind of. again, that first part where I was explaining that circle, that's where rad 3 over 2 actually comes from. Right now, though, you'll be given these top 9 values. Okay, so right now I'm going to give you those. You should have those out in front of you when you're doing this IXL. And we know cosine of 30 in a couple of different ways. If you understood that unit circle stuff, you understand it that way, that's fine. But I give you that cosine of 30 is rad 3 over 2. Okay, so there is a reason behind it. It has to do with that circle on the left. But that we will study that in algebra 2. We'll study that in pre-calculus. I just want to let you know that, again, there is a reason for these numbers. But let's not worry too much about it right now. Let's just focus on the right triangle stuff. So given this, now we have rad 3 over 2 is equal to the adjacent over 6 rad 3. Okay, so we are right here. And we need to solve for the adjacent side. Okay, so in order to do that, we need to get 6 rad 3 out of the denominator because we just want to get adjacent by itself. So we need to multiply by 6 rad 3 on both sides. And we are left with 6 rad 3 times rad 3 divided by 2, and that is equal to the adjacent side. And then we need to simplify that numerator. So 6 rad 3 times rad 3. The first thing that you should see is that these rad 3's, there's 2 of them and you're multiplying them together. So that just becomes 3. So then 6 times 3, that's 18. That 2 stays in the denominator. And then 18 divided by 2 is just 9. So the side that we're looking for, HG or GH, is 9. Okay, so again, I'm going to pause there. What questions do you have? What if the radicals don't cancel and become a whole number? Well, then we just have to deal with that radical. So if we can simplify it in any way, we have to simplify it. Which, again, we've been doing for the last couple of weeks. So we should be pretty familiar with that. Wouldn't it be easier to sine 30 and then multiply it by the hypotenuse and skip all the stuff in the middle? If I'm understanding your question correctly, you'd be finding the opposite side. So you'd be finding FG. Right. So if you did sine of 30, we'd be dealing with the opposite side, not the adjacent side. Which we want to find the adjacent side, not the opposite side. Okay. Or cosine. That's what we did. We did cosine of 30. That's rad 3 over 2. And then we solved from there. So what you just described is exactly what we did. If you have questions, that's okay. I want to do a couple more of these. Is it rad 9 or just 9? Okay. In this highlighted part, we simplified that numerator. So rad 3 times rad 3 is just 3. Okay, so that's that number in red. And then 6 times that, that's 18. Just 18. No radicals, no nothing. Just 18. And then we have all of that over 2. And then 18 divided by 2 is just 9. So as soon as you cancel out a rad and there's no radical left, it's just a number. All right, second example. Again, I'm taking these directly from the homework. Okay. Um, so given this right triangle, we want to find RS. Given an angle of 60 and a side of 16. So the first thing we do, again, is define what terms we have and define what terms we need. All right, so we need RS, which is this side right here. And then we determine just what sides we have and maybe define a little bit more what side we actually need. All right. So again, let's start with the hypotenuse. If we draw a line from our right angle, this side is the hypotenuse. If we draw a line from our angle to the other side of the triangle, that's our opposite. And the other side, that's the adjacent. Okay. So now let's just explicitly state all of that. So we have an angle. That angle is 60 degrees. We have a hypotenuse. And we need the opposite side. Okay, again, just define what we have and define what we need. So we have theta, we have hypotenuse, and we need opposite. So if we just remember what each of these trig functions actually mean, we can use it to find what we need. All right, so we need opposite given hypotenuse. So opposite and hypotenuse, which means we're using sine. All right, so sine of theta is always equal to opposite over hypotenuse. And again, then we're just substituting in what we know. We know that our angle is 60. We do not know the opposite side. And the hypotenuse is 16. Are there questions so far? So once we have all this, then we can substitute one more time. So given all these values up at the top of your screen, we know that sine of 60 is rad 3 over 2. So we can replace this sine of 60 with rad 3 over 2, and that is going to be equal to the opposite side over 16. And then we solve for the opposite side, okay? So we need to multiply both sides by 16. So we get 16 rad 3 divided by 2, and that is equal to the opposite side. And then after that, we need to rationalize, simplify, and get it in a form that is kind of acceptable, right? So we need to simplify 16 rad 3 divided by 2. So we can cancel out factors of 2 in both the numerator and denominator. Or in other words, just do 16 divided by 2, which is 8. So this becomes 8 rad 3, and that is the opposite side. Questions about this problem? Where did the 2 go? That 2, it's 16 divided by 2, that's just 8. So common factors of 16 and 2, that's 2. Take 2 out of 16, that's 8. Take 2 out of 2, that's 1. Or again, just 16 divided by 2. Okay, I want to do maybe one or two more examples. One that's a little bit more like this, and then one that's exactly the way I taught it last class, right? Um, so give me 1 second. How would you multiply two different rads? That's what we did up here. If it's duplicated, it just simplifies to what's under the radical. Okay, but if we had like rad 7 and rad 2, and again, we've gone over this, so we should know how to do this. If you have two things under a radical, you can multiply them together. Okay, so rad 7 times rad 2, that's rad 14. All right, so in this example, we want to find yz. Again, the first thing we have to do is to define what sides we have and define what sides we need. Okay, and this angle is the right angle. So the first thing we do, just find the hypotenuse. So if we take a line from our right angle, it's the other side of the triangle, that's our hypotenuse. If we draw a line from our angle to the other side of the triangle, that's our opposite. And then the side left over, that's our adjacent. So we have an angle theta that's equal to 60. We have a hypotenuse. And actually, I guess we don't even need the hypotenuse because we were trying to find this adjacent side. So we have adjacent and we have opposite. So we have the opposite side in an angle, and we're trying to find the adjacent. Okay, so if we have opposite and we're trying to find adjacent, we can use tangent because that uses both of them. Okay, so tangent of theta is always equal to opposite over adjacent. Okay, and then again, then we can just substitute in what we know. So I'll pause for a second there. Are there any questions about how I got anything up on your screen? So the next step is then take that substitution to the next step. So we go up to our values, find tangent of 60, and replace it with rad 3. Okay, and we want to solve for the adjacent side. And I'm guessing this is another place where people could start to screw up. Okay, so when we were finding the adjacent side, I'm going to do this step by step. If you already know how to do this, that's okay. But I'm going to show you what's actually happening. Okay, so we're trying to solve for this denominator down here. In order to do that, really what you're going to do is you're going to flip this value with this value. Okay, but what you're actually doing is you're multiplying by the denominator on both sides. Then they would cancel. So you'd have the adjacent times rad 3 is equal to 4 rad 3. Then we would have to divide by rad 3. in order to get the adjacent side by itself. And then we'd have the adjacent side is equal to 4 rad 3 divided by 3 divided by rad 3, which we can simplify because these rad 3's cancel. They're common factors. So then we have the adjacent side is just equal to 4. Questions about this example? How do I do this if the tangent is of 30? So tangent of 30, it's all the same, except instead you're using this value up here. It's all just substitution. I'm giving you those values. All right, and I want to do one quick example of the later points in this IXL, so R8. And this starts at like 75. So I'm going to get one of those ready, and then we will do that example. Why do you cancel the root 3 instead of multiplying it by itself? You can multiply it by itself, but there are also common factors in the numerator and denominator. So because of that, you end up just having rad 3 divided by rad 3, which those just cancel out and become 1. So you could do that. You could do exactly what I told you to do in order to rationalize. But you can also see that rad 3 divided by rad 3 is just 1. So they cancel and it's already rationalized. All right. The later points in this IXL, this R8, again, is exactly like we did last class. Okay, in this case, though, we are given kind of stranger values of theta, so it's not 30, 60, or 45. In this case, it's 56. Okay, so when it's a different value like that, when it's not a 30, 60, or 45, then that's like a signal kind of to use your calculator or Desmos. Okay, so this problem says find x, y, and then write your answer as an integer or is a decimal rounded to the nearest tenth? Okay, so usually the directions in these cases just give you about what you need to do. So if it says give a decimal rounded to the nearest tenth, that's a cue to use your calculator. If it says answer in rationalized simplified form, then we have to do what we had just done in the previous examples. Okay. But again, everything is kind of the same up until we actually have to substitute cosine of something for a value. All right. So the first thing we always do is just define what terms we have and what terms we need. Okay, so we want xy. So we want this side right here. All right, and then we should define what terms we actually have. So if we draw a line from our right angle to the other side of the triangle, that's the hypotenuse. If we draw a line from our angle to the other side of the triangle, that's our opposite. And then the other side left, that's the adjacent side. Okay, so we have a hypotenuse and adjacent. We have a hypotenuse and we need adjacent. And we have an angle of 56. So from SOHCAHTOA, again, we have we have hypotenuse and we need adjacent. So we want to use cosine. So then cosine of our angle is equal to adjacent over hypotenuse. And then we can substitute. So I'll pause there for a second. Are there any questions up until this point? Okay, so from here, we would need to use our calculator. So what we would do is if you have a calculator, you would type in cosine and then 56, and then you'd get a decimal. All right. So when you do that, and actually I'll bring up Desmos here. So we want cosine of 56, and we want that in degrees. Okay, so if you're going to get, we need to make sure our mode is in degrees. So if you have a TI-84, you would hit mode, scroll down to where it says radians or degrees, highlight degrees, and hit enter. We did that last class. But if you're on Desmos, you go to this little wrench icon in the top right, and then highlight degrees, and then it's in the form that we want. So then we would just type in cosine of 56, and we'd get a decimal, okay? Now, in our problem, we have the adjacent over 6 is equal to cosine of 56. So really what I would do first is multiply both sides by 6. That way we get the adjacent side by itself, and then the adjacent is equal to 6 times the cosine of 56. So then you can multiply that by 6, and we get the answer 3.3551. 1, 5, 7, 4, etc. Okay, but this example wants us to round to the nearest tenth, and that is the first decimal place. So because the next one is 5, we round up, so it's 3.4. And I get that I'm going to a calculator and I'm doing a couple of things, so I'm going to pause there. Are there any questions? All right, since there are no questions, I'll leave this open for the next minute or so. Um, if you have any general questions, now would be a great time to ask. Otherwise, as soon as I close it, I'll start a meeting on Teams. And if you need like specific help, I will be there. Okay. Again, this homework R7 and R8, this is due on Thursday. Um, and it's everything that we did today is R8. Everything that we did last class, that you should be able to do that using our last class's lecture. All right. So that's inverse trig. All right. So again, I'll leave this open for the next minute or so. After that, we'll go to Teams. All right, so I'll close this. I'll start a meeting on Teams, and if you have specific questions, you can ask there. All right, so I will see you there.